In order to learn about the materials and minerals on the Earth, we need to first learn about the Earth's internal structure. The Earth has three primary zones. The outermost layer or zone of the Earth is the crust. This is a very thin shell of hardened material on which we live. Now, just to illustrate how thick the crust really is of the Earth, imagine an egg. You break an egg open, compare the thickness of the shell of an egg to the inside of the egg. Well, the thickness of the shell compared to the rest of the egg is actually thicker than the crust is compared to the interior of the Earth. Really, all things considered, the crust of the Earth is extremely thin. Beneath the crust, we have the mantle, which is a layer of molten materials. Has been molten since the Earth was first formed and will be for many millennia. It's a layer that is much, much thicker than the crust. Inside of the mantle is the core, the very center of the Earth. The core has two layers, the inner core, which is solid, and the outer core, which is partially molten. These are the three main zones of the Earth's interior. I won't go into any more now because that is discussed in chapter 18, which we'll discuss later when we talk about plate tectonics. Now, that's important to understand what the Earth is made of. On the graph on the right, the top shows the materials in the Earth's crust, but the bottom shows the materials of the entire Earth. Notice that 1/3 of the Earth is made of iron, and just under 1/3 of the Earth is made of oxygen, and the other 1/3 of the Earth is made of silicon, magnesium, nickel, calcium, and other materials, many other materials. Now, at the surface of the crust is made primarily of lighter elements. For instance, remember that 1/3 of the Earth is iron. Well, only 5% of the Earth's crust from the top figure is made of iron, whereas nearly half of the crust is made of oxygen, and well over 1/4 of the crust is made of silicon. So there are basically 8 elements that make up 98.6% of the crust. The primary two, of course, being oxygen and silicon, as I just mentioned. The others being aluminum, iron, calcium, sodium, potassium, and magnesium. These are the materials that make up the rocks and the minerals in the crust. If you get down into the mantle and the core of the Earth, this is where most of your heavier elements, such as iron and nickel, are located. So a mineral is a naturally occurring inorganic solid element or compound with a crystalline structure. Basically saying it is a naturally occurring substance where you have a repeated pattern in the orientation of atoms. Take this figure, for example. We talked in the chemistry section about salt, sodium chloride, also known as halite. It has an alternating pattern of a sodium and chlorine atoms, and it gives you a 3-dimensional cubic structure. This is what we mean by crystalline structure. These materials can't be synthetic. They are not produced by any living organisms, and they have to have this regular repeating crystalline pattern. Now, I need to point out one word in this definition. We said it's a naturally occurring inorganic solid element. Now, don't confuse this inorganic with the popular term in our culture today. Usually we talk about something organic, meaning there aren't any pesticides or hormones or any artificial growth stimuli for produce and milk and meat and food. When we talk about the Earth, organic doesn't have anything to do with the food specifically. What we really mean by organic is that it's made of compounds with carbon as the main element. That's what we mean by organic. So inorganic are compounds made without carbon. There's an entire section of chemistry dedicated to organic chemistry, exploring all of the molecules and reactions involving organic compounds. If we look at the crystal structure, these crystals can be made up of one single element or multiple elements. We already saw one with multiple elements. That would be salt, halite. Another good example would be quartz, which is a combination of silicon and oxygen. An example where a crystal structure is made up of one single element would be a diamond, because diamond is made only of carbon attached to carbon attached to carbon, just carbon bonds throughout the entire diamond. Now, minerals can have this crystalline structure in different shapes based on the arrangement of the elements in the composition. For instance, we already saw halite, salt, is cubic. That's what we're seeing here in this picture. Those look like salt crystals inside of this picture. Another example would be ice. Ice is made of water, of course, H2O, two hydrogens and an oxygen in one single water molecule. When these water molecules attach to each other, they create a hexagonal crystalline structure. Now, since silicon is one of the primary elements in the crust, we can divide the rocks and minerals in the Earth's crust into silicates and non-silicates. A silicate is a mineral that contains mostly silicon and oxygen. This actually makes up about 92% of the Earth's crust. Now, all of these silicates are based on a tetrahedral pattern with silicon at the center and 4 oxygens around the silicon. Gives almost a pyramidal type of structure. Now, there are 4 different types of arrangements of these tetrahedral units. You can have an isolated tetrahedron, just one simple silicon-oxygen compound, just individual on its own. Or you can have a chain of silicates, as you see in graph B of the figure I just pulled up, where you have multiple chains linked together, or multiple units linked together in a long chain. And then you could have a 2-dimensional chain, which would be called a sheet, which you see in figures C and D of this figure. Or you have a framework of silicates, where there are regular 3-dimensional patterns involving these tetrahedral units of silicon and oxygen. Non-silicates are far more rare. We saw that silicates make up 92% of the crust. Non-silicates only make up the remaining 8% of the crust. The definition of non-silicate then would be that there are none of these silicon-oxygen tetrahedrons in the crystal structure of these minerals. There are 8 groups of non-silicates, and these are listed on the right as carbonates, which are the most abundant, sulfates, oxides, sulfides, halides, phosphates, hydroxides, and other native elements. Here is a graph from your textbook. This will be a very helpful chart for you to hold on to for the rest of this chapter. Breaks minerals down into silicates on the left and non-silicates on the right. The basic the basic silicates that we deal with are ferromagnesians, ferro meaning iron and magnesium meaning magnetic, magnetite type of structure, non-ferromagnesian, and then you have clay minerals. And then on the right, of course, you have your non-silicates, which we just described. So keep a hold of this chart throughout the chapter. It'll be very useful as we talk about the different types of rocks and minerals.